About this question is obviously about area and volume of a cylindrical container and also a conical vessel. So the first thing is some preparation work. You must remember a cylinder with a base radius with the height, so the volume is equal to pi r squared, the circle, times height. This is the volume of a cylinder. So another object is talking about an inverted conical vessel. The radius is r, the height is h, then the volume is talking about 1/3 times pi r squared, the circle, and also time height is 1/3 of our prism. So apply to this case, the very important thing is you need to draw properly and understand what is asking here. They say there is a cylindrical container with the base radius is 8 and then the height is 64, and there is an inverted circular conical vessel with the base radius is 20 and the height is 60. So the container is fully filled with water. So the container, all the space here are water. And then they say that after that they put all this water into this vessel. We are going to find the volume of water. If you draw clearly, if you read carefully, then we are talking about the volume of the cylinder. It's not related to the conical vessel yet. So we are just talking about given volume of water is equal to, that means volume of the cylindrical container. So that's why we just simply apply the volume of this is pi r squared times the height, and the r here is 8 squared, and then height is 64. So this is 4096 pi cm cube. That's the answer of part A. It's totally not related to the cone here. It's just talking about the cylinder. So read the question very carefully and make sure you know what is asking. Continue to part B. We need to find the depth of the water. So what happened next? The water flow inside the conical vessel, and then will the water overflow? So it is like this, or finally the water will flow outside, is we need to calculate. So in part B, we start from calculate the volume of the whole conical vessel, see whether it is big enough. Is equal to 1/3 pi r squared h. R here is 20 while the height is 60. So we calculate this, then we got 8,000 pi cm cube. So the volume of water is just 4,000 something pi, and the total volume of the container is 8,000 something 8,000 pi. So it's big enough to contain all the water. So it will not overflow and should be like this. After that, we focus on the cross section here. We know the cross section here is 20 is the base and the height is 60. So if we use similar method to consider the water cross surface, I want to know the depth, so I let it be h. Even though I can't get the value, of h, this to this, the ratio is 3 to 1. So I may simply change, I can find out if this is h, then this one should be h divided by 3. Because 60 divided by 3 give you 20. So h divided by 3 give you the base radius in terms of h. So now, no matter the base radius or the height, we can all express in one single unknown, which is x, so that we can form equations. Okay, now volume of water, we already know is 4096 pi cm cube. And at the same time, we can express in terms of this version, in terms of h, so that we can find out their relation. It's 1/3 pi r squared times height is equal to 4096. In terms of h, the base radius is h/3 and the height is h. So we successfully form an equation with h be the only unknown. Then we can solve h later on. So pi over 27 h power 3 is equal to 4096 pi. H power 3 is equal to 110,592, and then we got 48. It makes sense. It's slightly less than this, so this one is 48 now. 48, and this is 48. We just mean this is divided by 3. That means this is equal to 16. We know very well about the cone now. So the depth of water is 48 cm. Finish part B, then part C. They ask if there is a metal sphere of radius 14. So a metal sphere, maybe it's like this, and then the radius is 14. Assume that it can be totally immersed in the water, and then we are asking will the water overflow. That means will the water inside together with this one overflow. So basically they are just asking you to compare two things. The first thing is the total volume of this container. The second thing is about the water and the sphere. So if I draw that out, that means one side is talking about the volume of the container, which is equal to 8,000 pi. We already find that out. And then compare the water. The water, the width we already know is 16 just now. The height is 48. And then this is not very good notation. Okay, 48 inside. And then together with a sphere with radius 14. So we are comparing this volume and this volume, see whether which one is bigger. So this one fixed it, and our target is this one now. So simple. 1/3 pi r square h. R is 16 while the height is 48. And then plus this one is 4/3 pi r power 3. So r here is 14 from the questions, or you don't even need to calculate again because we already get the volume of water. It's so stupid. So volume of water is 4096 pi, and then you calculate that. So this is 7754.67 something pi cm cube. So now we can compare two values. Our space is this amount, however we just need to use this amount of space. This is less than 8,000, so we have to stay clearly. This is less than 8,000 pi. Therefore, will not overflow. In reverse, if you find out that this amount we need more space, more than 8,000, then you will say that the water will overflow. In this case, it will not overflow.